Hey everyone, thanks for being here. I'm Smita Verma. I'm a senior product manager at Adobe, where I focus on security, compliance, and platform health. So basically, I spend my days thinking about how to keep massive scale systems running smoothly and securely, which means I've seen my fair share of alerts that crash family dinners and ruin weekend plans. So, today we are going to talk about something that's probably keeping a lot of you up at night too, which is incident response. But here's the good news: we're going to explore how AI is changing the game from sending alerts to actually doing something about the problems before they blow up. So let's be real for a second. How many of you have had phone blow up with alerts right in the middle of something important? Maybe during a presentation or worse, on a date. Yeah, I see you. We've all been there. And here's what we're dealing with: modern systems that are throwing thousands of signals at us every single minute. And when something goes wrong, we have got maybe minutes or sometimes just seconds to fix before literally everything cascades into a full blown outage. And it's not like the old days where you have a monolith, you have a database, and you know you can deal with it. Now you have got microservices that are talking to containers running across multiple clouds with Kubernetes orchestrating everything. So it's a beautiful mess. The truth is, the traditional approaches, they just can't keep up anymore. Human-led incident response doesn't scale, even when you're managing this level of complexity. And that's the problem that we need to solve. So here's where it gets exciting. AI-powered autonomous systems are completely changing how we handle incidents. Think about it this way: instead of just alerting you that something is wrong, these systems can actually see the patterns across all those disparate signals. They're looking at metrics, logs, traces, everything, and connecting the dots that human would miss. But here's the really cool part: they just don't detect problems. They classify them with context, figures out how serious the threat is, and then actually responds using predefined playbooks. So we are talking about machine speed here, seconds, not minutes. And the best part, they learn. Every incident makes them smarter. They're continuously improving their detection and response capabilities based on what they have seen before. So instead of interrupting your morning coffee or your kid's soccer game, these systems are often resolving issues before you even know that there was a problem. And that's a game changer. All right, so let's talk numbers because that's where it gets really impressive. So we are seeing a 60% reduction in mean time to resolution. And think about that. Incidents that used to take an hour are now resolved in 20 minutes. Some are fixed in literal seconds. False positives under 5%. And that's huge because it means you can actually trust the automation. You're not getting woken up for nothing. And unlike your on-call rotation, these systems, they provide 24/7 coverage without getting tired, without needing coffee, without making mistakes because they are exhausted. And oh, the ROI, 95% in the first year. That's not just about cost savings, it's about your system reliability engineers focusing on building cool stuff instead of firefighting all day. So let me show you what these systems can actually do when an incident happens. So first, network segmentation. So if something is compromised, the system can automatically isolate the network segment to stop the threat from spreading. Not waiting for someone to manually update firewall rules. Container isolation. So you have a suspicious container, quarantine immediately. while the system spins up clean replacement to maintain service availability. Your users don't even notice. Dynamic resource allocation. The system sees a service struggling and it automatically redistributes compute resources to keep critical services running smoothly. And then my favorite, automatic rollbacks. You push a deployment, it starts degrading performance, and boom, the system is back to the last known good configuration before your users even start complaining. And this is expert level response happening here, which is happening in seconds. No human team can match that speed, no matter how good they are. So let me walk you through a real incident to show you how this works in practice. So in t plus 0 seconds, the system detects anomalous query pattern hitting our primary database cluster. Something is not right. In 1.5 seconds later, it's classified that this is a potential resource exhaustion event and the database is about to get overwhelmed. In 3 seconds in, automatic query throttling kicks in for non-critical services and we are protecting the database. 6 seconds, the read traffic is being rerouted to a secondary replica to spread the load. In 30 seconds, now your engineering team gets an alert, and here's the thing. It comes with diagnostic data and the incident is already contained. Traditional monitoring would have alerted after the database was already struggling. By then, basically, you're looking at a potential outage which is affecting millions of users. So instead of this was handled before it became a problem. That's the difference between reactive and autonomous. So here's another one that really shows the power of behavioral based detection. A 0-day vulnerability gets exploited in our environment. Traditional security tools, they have got nothing. No signatures, no known patterns. But with our machine learning powered system, it notices that something is off. The processes are behaving abnormally across multiple instances, traffic pattern looks suspicious. Within seconds, it's isolating the affected containers, filtering malicious traffic, and capturing forensics data for the security team. The attack was contained, no data exfiltration, no spread to other systems. That's why behavior-based detection beats signature-based every time. You can't have a signature for something that's never been seen before, but you can detect when things aren't acting normal. Now, I'm not going to stand here and tell you that this is easy. This is a real challenge, and we need to think about it. Algorithm reliability. How do you trust a machine learning model to make the right call in a scenario it has never seen before? So, our solution is confidence scoring. If the system isn't sure, it escalates to human. We also continuously retrain with new incident data and do the regular adversarial testing. Integration complexity, you have got existing monitoring tool, different cloud providers, legacy systems. It's messy. Start with standardized API adapters for major platforms. And here's a pro tip. Start with read-only access before you let the system take actions. Human oversight. You need the right balance. Too much oversight and you lose the speed benefits. Too little and people get nervous. We have used tiered autonomy. The system earns more freedom as it proves itself reliable, and there's always an instant override button. The key is you start small and build confidence over time. Now, here's the thing. Engineering team, they won't trust a black box, and they shouldn't. That's why decision tracing is critical. Every detection, every confidence score, every action taken, it's all logged. You can see exactly what the system was thinking and why it did what it did. Explainable AI takes this further with visualization tool to show the model's reasoning with in human terms. So you can replay incidents step by step and see the decision process. And then collaboration interface. These are dashboards that are designed for humans and AI to work together. You can see what automation is doing, understand the context, and override with one click if needed. This transparency is what turns skepticism into trust. When your engineering team can see and understand the system's reasoning, they become advocate instead of resistors. Now, let's actually talk about how to implement this. And here is a roadmap, a sample roadmap that works. Let's start with an assessment phase. Start by inventorying your current incident types and response procedures. What are you dealing with most often? Next is monitoring and enhancement. Monitoring enhancement. Make sure you've got rich telemetry. The AI needs data to work with. Then passive learning mode. This is crucial. Deploy the system in observation only mode. Let it watch, learn, and show you what it would have done. This builds confidence without risk. Supervised automation. Now enable response action, but with human approval. The system recommends, you approve it, and it executes. And then last is full autonomy. Gradually expand the system, um, gradually expand what the system can do on its own, starting with low risk, well understood incident. This progressive approach balances innovation with risk management. You're building confidence at every step. All right, so let's wrap up with key points to remember. Number one, speed is critical. Autonomous system operates at machine timescales. They prevent cascading failures before human can even start responding. Start small, scale fast. Don't try to automate everything on day one. Focus on common, well understood incidents first. Human AI partnership. We are not trying to replace engineers, we are elevating them. Let automation handle the routine stuff so your team can focus on complex, interesting problems. Measure everything. You need comprehensive metrics to prove value and guide continuous improvements. And then the data speaks for itself. 60% faster resolution, under 5% false positive, 24/7 coverage. This is the future that every site reliability engineer dreams for. And then start with high volume incidents. Use observation mode to build confidence and then gradually automate. The goal is augmenting human expertise, not replacing it. All right, that's a wrap for my presentation today. Thank you so much for your time today. I hope you enjoyed my presentation and I hope you have a really nice day. Thank you so much.